Hello students. Today let us study about this coordinate geometry. For this instant I am going to derive the formula for distance, to find the distance formula for today, and we shall solve a model problem for that one, verification. Okay, so here as usual I told you already, the coordinate geometry is the branch of geometry where the position of the points on the plane is defined with the help of an ordered pair of numbers called as coordinates. Here, for the knowledge sake, you should know the Cartesian plane is the plane with the rectangular coordinate system that associates each point in the plane with a pair of numbers. So x coordinate and x coordinate and y coordinates here. The two perpendicular lines are the coordinate axis. The horizontal line is x axis and the vertical line is y axis. You know this one. The coordinate axis divide the plane into four quadrants, and the point of intersection is the origin. The coordinates of the origin is 0, 0. The distance of a point from the y-axis is called x-ordinate or abscissa, and the distance of the point from x-axis is called as y-ordinate or ordinate simply. The point is represented as p of xy. So we discussed this yesterday in the introductory part. So that means you can say where the p located, or if I ask where is the q, what is the position of q, means you can answer no. The coordinate of the origins means it is 0, 0. Okay, so by knowing this, let us find the distance between any two points in a Cartesian plane, two-dimensional plane. Let us find the distance between 2 points. It is called as a distance formula. Let us derive. This derivation is not there for your exam, but you have to remember the formula. Okay, let us find the distance between any 2 points. Let me call them as p of x1, y1 and q of x2, y2. Let me consider those 2 points in the graph or in the Cartesian plane, two-dimensional plane here. So let the p of xy be in a plane, it is there, and let me consider one more point q of x2, y2 in the another part. Let us find the distance between these 2 points is given by pq, no? So I have to find this distance here, pq. Okay, for that draw PR and QS perpendicular to x-axis here. Actually that point R represent x1 and point S represent x2 here. The difference between x1 and x2 is x2 minus x1, because x2 is greater than x1, no? That's why. So difference is, the length of RS is x2 minus x1. Okay, in particular that is 2, and it is 6, no, 6 minus 2 gives 4 centimeter is there actually that. But in general, if I consider R as x1, S as x2, the difference of those 2 points is x2 minus x1. Length of RS is x2 minus x1, we can say. So let us a perpendicular from point P on QS drawn to meet at the point T here. A perpendicular is drawn on QS from P at T here. We make PTQ triangle there. So actually now that Q on y-axis it is y2, the position of y-ordinate is y2 and t is y1 now. So that means length of QT gives, what is the length of QT now? TQ, length of TQ is y2 minus y1, because y2 is greater than y1, no, that's why. Now then OR is x1, of course, OS is x2, length, OS is greater than OR, no, that's for, therefore so RS is equal to and pt is equal to rs is equal to x2 minus x1, difference of those, that distance. Now similarly qt is given by y2 minus y1. Okay, so now we getting a right angle triangle, no? So apply Pythagoras theorem for triangle ptq, right angle triangle ptq, where t is equal to 90 degree, pq is the hypotenuse, pt is the base, tq is the height. Now that is pq square is equal to pt square plus qt square, no, base square plus height square. pq square is equal to pt square plus qt square. What is pt now? pt is actually x2 minus x1 whole square plus qt is y2 minus y1 whole square. So therefore the distance between pq is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is called as distance formula. Actually this is the distance between 2 points pq here, anyway, any 2 points in the coordinate plane. So this is called as distance formula. Distance formula is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. So if that line originated from the origin, what happens, you see? Then x ordinate and one of the y ordinate becomes 0 there. Then the distance from a point from the origin, the distance of a point from the origin means that line starts from origin 0 0. Then the distance of the point p of xy from the origin 0 0 is given by d is equal to square root of x square plus y square. Here at the point q, x ordinate is there, y is 0, and the length of x here perpendicular on y axis, there y ordinate is there, x ordinate is 0. Okay, therefore the distance, if we put x here, x1 is there, y1 is not there. Here x2 y1 y2 is there, y1 is not there. Okay, if you substitute those values in the distance formula, we will get this d is equal to square root of x square plus y square here. Let us solve apply some problems regarding this distance formula. Let us find the distance between 2 points using distance formula. Okay, for that let me consider one problem here. Finding the distance between 2 points. Find the distance between the points 2 3 and 4 1. So here 2 3, 2 is the x1, 3 is y1, 4 is x2, 1 is y1 y2 here. So here x1 y1 is equal to 2 3 and x2 y2 is equal to 4 1. Let us substitute in the distance formula these two values here. That means distance formula is given by, again, d is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So by x2 is here 4 minus x1 is 2, 4 minus 2 whole square plus y1 is y2 is 1 minus y1 is 3, 1 minus 3 whole square. So within the square root, d is equal to square root of 4 minus 2 is 2 square plus 1 minus 3 is minus 2 whole square. Means here d is equal to square of 2 is 4, minus 2 whole square is plus 4 here. Minus 2 into minus 2 is plus 4. Again 4 plus 4 is 8. D is equal to square root of 8. 8 we can split as 2 4s, no? Because 4 is a perfect square. Let us take out from the square root. D is equal to square root of 4 into 2 we can write. If you take 4 out of the square root of 4 is 2, no? Therefore d is equal to 2 root 2 units here. This is the distance between those 2 points, 2 root 2. Similarly, we shall solve one more problem. The point originated from the origin here. Find the distance of points 3 4 from the origin. Here we have to find the distance from the origin of this point 3 4. So here xy is given by 3 4. Therefore distance from the origin is given by the formula d is equal to square root of x square plus y square. So that is equal to d is equal to 3 square root of 3 square plus 4 square. D is equal to square root of 3 square is 9 plus 4 square is 16. Square, that is D is equal to square root of 9 plus 16 is 25. Square root of 25 is D is equal to 5 units. Okay, in this way we can find the distance between any 2 points in a coordinate system by using distance formula. So I derived. You have to remember these two formula to find the distance. Okay. In the next class we shall solve some more problems, application problems regarding this distance formula and the points from the origin and application on triangles and application on the triangles and rectangles, that is quadrilateral properties we can verify. Thank you, students.